Hello coders, welcome to my channel. I am Aniket and today we will discuss problem from GFG, that is max dot product with zero insertions. Let's read the problem. Given two arrays A and B of positive integers of size n and m respectively, where m is always lesser than equal to n, and you are allowed to insert 0 anywhere into the second array B so that its length become equal to n. The dot product of two array of equal length n is defined as this a0 into b0 plus a1 into b1 and so on till an minus 1 into bn minus 1. Return the maximum possible dot product of the two array. So you have to return the maximum possible this value while assigning some places of b as 0 so that its length will become equal to n, because its length initially is m, which is lesser than equal to n. So to make this length equal to this value n, you have to insert some number of zeros. What are the number of zeros you have to insert? The number of zeros is nothing but you have to insert n minus m number of zeros into b. I hope you understand it. Now let's discuss a test case. So here this is our array A, and this is our array B, 3, 6, 7. So if you put a 0 here and if you put a 0 here, your array will look like this: 0, 3, 0, 6 and 7. Now if you do a dot product of A dot B, so it will simply equal to A0 into B0 plus A1 A1 into B1 and so on till A of n minus 1 till B of n minus 1, because now length of B is also become equal to n. So I hope you understand it. And when you do dot multiply with A0 with B0, you got 0, and for this you got 9, for this you got 0, for this you got 42, and 8 7 8 times 7 is 56. So if you add it all, you get 107, and it is our maximum answer. So in this way you can easily dry run this test case. Now let's discuss the approach of this problem. The first question arises is, can we solve this using greedy method? Like we want to maximize something, so can we take maximum value of a0 into maximum value of b0, then second maximum value of a1 to second maximum value of b1, so just like this? So the answer to this question is no, we cannot. Why? Because while inserting zeros, the order of elements remains as it is, not changing. So we only allowed to update our array or sort our array when there is no restriction in ordering. But if you carefully see, when you insert zeros in the array B, you will find that the order of non-zero elements in B array will be same. Like in this case also, if you insert 0 anywhere, the order of non-zero element will remain 3, 6, 7 only. You can't change this order. So that's why it is a type of subsequence problem. Subsequence problem. And you can't change the order, so that's why we cannot sort the array and perform greedy method. I hope you understand it. Now what is the optimal method to do this? So we can use DP method to solve this problem. So now the question arises that what are the various parameters? What are the various parameters we should consider in we should consider in recursion? And if we are able to write the recursion code, then we can simply do it memoization. The memoization step is not that big deal. So the first parameter is id, which is denoting the index of array b, and the second parameter is k, which is denoting the current number of 0 present in array b. And in this DP problem, we have two types of choices. We have two types of choices. What are those? Place a bi, that is a non-zero element, and place second choice is place a 0 in place of bi. Now we will discuss the state transition in both cases. So what happen if you place a bi? Place a bi. So let's say your previous state is id comma k, and if you place a bi, then you have to go to id plus 1, and your k will remain as it is because k is representing the current number of 0 present in array b. So that's why you don't put any 0, so that's why your k remain as it is. What is the state transition when you place a 0? So when you place a 0, let's say your previous state is id comma k. So the next transition is you will remain the same index for bi because you don't place bi. So that's why you have to remain at that index only, and your k will decreases by 1 because now there are one more 0. So that's why your k will increases by 1. So there are only these two type of so there are only these two types of transition we have. But a question arises that can we place 0 anywhere? So the answer to this question is no. We can only place 0 if we have k is lesser than n minus m, that is number of allowed zeros. So the value of k should be strictly less than this term n minus m. In that case only we are allowed to place a 0, otherwise we have to place bi only. Now let's discuss the code, but before that please hit the like and subscribe button so that you can't miss any future explanations of the POTD discussions. So please ensure that you hit the like and subscribe button because it will motivate me to create such kind of intuitive video for you. So let's jump to the code now. So here is my simple Java code for this problem, where I initialize these terms globally so that we have limited number of parameters in my main recurrence function. So first of all, I will call my memo of 0 comma 0. This 0 is denoting that index, and this 0 is denoting that current number of 0 in array B. Initially you are at 0 index and initially you have 0 number of 0 in your array B. Before discussing the base case, first discuss the body of this recurrence function. So case 1 is denoting the place a zero case. So when k is lesser than n minus 1, then you have to call a memo of id comma k plus 1, just I discussed before also, because after placing a 0 your k will increase by 1, and since you don't place bid, so that's why your id will remain as it is, don't increase it. Since you are placing a 0, so if you do 0 into a of id plus k, you will get 0 only. So that's why we don't include this term in this statement. Now let's discuss the case 2. Case 2 is the place bid. So if you place bid, then you have to multiply this bid to id plus k. This will increase to your answer, and finally call your memo of id plus 1 comma k for the remaining states. Many of you confused that why I take aid plus k, don't why I not take a of id simply. I take this term because k means current number of zeros in B. So you have to add this term to your current index so that you will forward A. So let's say this is id plus k of A, and this is B of id. Since you place 0 in any of these before places, so that's why you have to map this id to this id plus k. I hope you understand this. That's why I take a of id plus k instead of simple id. So in this way you have to finally return the maximum of case 1 comma case 2 and store it into your dp of id comma k. So now let's discuss the complexity of this problem. So the complexity of this problem is nothing but O of m into k, and if you expand the term k, that is nothing but n minus m plus 1. So if you approximate this complexity, you will find that your complexity is of order O of m cross n, and this is easily acceptable in our uh, problems because its constraint is under our limit. I hope you understand my code and the intuition behind this code. Please hit the like and subscribe button so that you will not miss any kind of POTD discussions in future, because it will motivate me to create such kind of intuitive video also. So please hit the like and subscribe button. Thank you for watching my video.